Today we're going to talk about precision and significant digits. Precision is the level of detail of a measurement. More precise measurements are obtained by using instruments marked in smaller units. So the smaller the unit, the more precise a measurement is. So for example, 568 centimeters would be more precise compared to 5.7 meters because centimeter is a smaller unit compared to a meter. What if we have the same unit of measure? For example, these two measurements are both in ounces. So we can't say one is more precise than the other because of the unit of measure. So now we look at decimal places. 31.32 ounces is more precise compared to 31 ounces because it goes all the way to the hundredth spot of an ounce, which is of course smaller than an ounce. So when we have the same unit of measure, you go by the number of decimal places that follow. The more decimal places that follow the decimal point, the more precise the measurement's going to be. So let's do some practice. We're going to go ahead and choose which of the two measurements is more precise compared to the other. Now, if the units are the same, we look for decimal places. If the units are different, we look for the one which is the smaller of the two. So here's an example. 21,676.5 pounds compared to 31 ounces. Which one's more precise? Well, I have two units of measure, two different units of measure. I have the pounds and the ounces. Ounces is a smaller unit compared to pounds. So therefore, we say 31 ounces is more precise. Here's another example. 4 inches and 0 feet. Now again, two completely different units of measure, inches and feet, so we go by the smaller unit. And we know inches is smaller, so therefore 4 inches is more precise. 6.77 meters and 676.5 centimeters. Centimeters is a smaller unit compared to meters, therefore centimeters is more precise. One more example. A mile and 5,280 feet. Now, these are equal in terms of measurement, but which one's more precise? Well, feet is a smaller unit compared to miles, so therefore 5,280 feet is more precise. So that's precision. Next, we're going to talk about our significant figures or significant digits. Significant figures are critical when reporting scientific data because they give the reader an idea of how precise the measurement is. Now, there are a handful of rules for significant digits. The first rule, all digits 1 through 9, which are called non-zero digits, are significant. So, for example, in the measurement 9.342 milligrams, we say that there's 4 significant digits because 9, 3, 4, 2 are all non-zero digits. In our next measurement, 233,124 miles, they're significant digits because if you take a look at that number, those values are all non-zero digits, 2, 3, 1, and 4. Non-zero digits, therefore they're all significant. So that's the first rule of significant digits. Our second rule, zeros are significant when they are between two non-zero digits. So for example, here 0 is a significant digit because it's in between 2 and 6, which are two non-zero digits. So we say 2.06 has 3 significant digits. 206 also has 3 significant digits, again because 0 is in between two non-zero digits. Here's another example. 100,001. 100,001 would have 6 significant digits. The zeros are in between two non-zero numbers. 1 is a non-zero number, and so is the 1 at the end. So these zeros are important. We'd include them when we're talking about significant digits. So we say there are 6 significant digits. Rule number 3. Zeros at the end of a number and after a decimal point are significant. It is assumed that these zeros would not be shown unless they were important. So in our number 138.000, those zeros would be significant. Because if they weren't important, we could simply represent that number as 138. So 138.000 has 6 significant digits. 0.250. Now here, the only zero that we're going to count is the one at the end, after the 5. Because again, it's at the end of a number after a decimal point, so that's important. The 0 in front of the decimal point, we would not include. It is not in between two non-zero numbers, and it's not after a decimal point. So we say 0.250 has only 3 significant digits. The 0 in front of the decimal we would not count. However, if there was a number like 2 here, 0.250, then that 0 would be counted and included, and we'd say that there are 5 significant digits. But again, because there's no non-zero number in front of this 0, we wouldn't include it. Here's rule number 4. A 0 to the right of a decimal point and a number less than 1, but to the left of a non-zero digit is not significant. Let's take a look at an example. In this number here, we say this number only has 4 significant digits. Now let me explain why there's only 4. These 3 zeros in front do not count. Because if we take a look at rule number 4, a 0 to the right of a decimal point and number less than 1, and obviously this number is smaller than 1, this 0 we do not include. Any 0 to the left of a non-zero digit, we don't include. So these 2 zeros here we're not going to include because it's to the left of a non-zero digit. The 0 here in between 2 non-zero digits we count as a significant digit because of rule number 1. And a 0 at the end here, we also are going to count as a significant digit because of one of the rules. So this number here we say only has 4 significant digits. The 1, the 0, 2, and 0 at the end, the last 4 digits. Here's another example. Again, obviously this number is less than 1, so the 0 here we do not count. These 3 zeros to the left of the 2, which is a non-zero number, we do not count as well. So we count the last 5 numbers. 2, 4, 2 are non-zero digits, so they are significant. And the zeros at the end after a decimal point, we include, those are significant. So we say this number has 5 significant digits. Rule number 5. Zeros at the end of a number without a decimal point are not significant. So if there's no decimal point, we have numbers at the end, we don't count them, they're not included. So for example, 1,000. There's no decimal point here. It's not 1.000, so we're not going to count those zeros. So 1,000 only has 1 significant digit. 1,010 would have 3 significant digits. The ones obviously are non-zero numbers, so we include them. The 0 in between 2 non-zero numbers we'd count as a significant digit. But the 0 at the end, we don't include because of rule number 5. Zeros at the end of a number without a decimal are not significant. So 1,010 only has 3 significant digits. 78,000 only has 2 significant digits. Again, there's no decimal point. So the zeros that follow the comma, we ignore. We don't need them. They're not in between 2 non-zero numbers. They're at the end of a number without a decimal point, so therefore there's only 2 significant digits. Let's do some practice. Determine the number of significant digits. 36,000 feet. 36,000 feet. First of all, there's no decimal point, The zeros that we see are not in between two non-zero numbers, so they don't count as significant. So 36,000 feet has two significant digits. Number 2, 1/100th of a kilogram. The zero to the right of a decimal point and to the left of a non-zero digit we do not include. So these two zeros we do not count. The only significant digit we have is the 1 at the end. So we say 1/100th of a kilogram has one significant digit. 15.0 liters. Well, 1 and 5 are non-zero numbers, so we're going to count that. And a 0 at the end, remember, zeros at the end after a decimal point are significant. If they weren't important, we wouldn't include it. It would just be 15. But because the 0 is there, it is a significant digit. So we say there's 3 significant digits in 15.0. Now we're going to talk about rounding. Rounding according to significant digits. We're going to take this number and round it to 4 significant digits, which means my final answer has to have only 4 significant digits. Now remember your rules for rounding. 5 or more we round up, less than 5 we round down. So if I'm looking at 4 significant digits, there's 1, 2, 3, 4. I'm going to round to the thousandths place. Well, take a look at the number to the right. It's less than 5. So we're going to round down to 3.774 liters. There's 4 significant digits. This time we're going to round to 3 significant digits. 3 significant digits. The 2, 5, and 5 are significant digits. We're going to look to the value to the right, 0.0, 5 or less than 5, we round down. So this would round to 255 kilograms. Round to 4 significant digits. 5, 5, significant. 2, 6, significant. Those are my first 4 significant digits. Look at the number to the right. It's more than 5, so we're going to round up to 55.27 grams.